Hi friends, welcome back. This is Srinivas Reddy. In the previous session, we have discussed about a brief introduction about the computer history, and in today's session, we'll discuss about computer and how basically computer works, and some introduction about the programming language. That we'll see it in today's session. So first of all, we'll see about what is a computer. So computer, I would say it's an electronic device which takes input. So everybody is telling the same thing. So everybody knows that, right? What is a computer? So if you divide the computer into two parts, we can divide them into two parts. One is a software components and other is hardware component. So first we'll talk about the hardware components. So hardware components means those are the components which we can see physically exist and we can touch those components. Example, printer, scanner, these are the peripheral devices, but inside the computer, if you take keyboard, mouse, monitor, RAM, all these are the physical components, those which we can see. So those are called hardware components of a computer. And next is software. We'll talk about software later. So first in hardware. Again in hardware components, we have divided hardware components into three parts. One is input devices, output devices, and CPU. First, input devices. So input devices means these are the devices through which we give input to the computer. Examples for input devices, keyboard, mouse, scanner, all these are the examples for input devices. Next, output devices. Output devices means the devices through which computer gives output back to the user. Examples for output devices are speaker, monitor. All these are the examples for output devices. Next, CPU. CPU stands for Central Processing Unit. We call it as brain of the computer. Why? Because whatever the instructions we are giving to the computer, all those instructions are processed by this CPU. This we can call it as a microprocessor or simply chip. So if you see the basic structure, it looks similar to this one. Not exactly like this, as just prototype. So this is a monitor, keyboard, mouse, and CPU. So whatever we are seeing here, right, this is not exactly the CPU. This we call it as an iron metallic core. Inside that CPU, we'll have motherboard, right? Inside motherboard, we'll have one slot where we put our CPU. That is a square shape. This is small inside the CPU. So that CPU is called brain of the computer, right? So those are the hardware components of a computer. So to interact with the hardware, okay, I'm an end user. Okay, I want to interact with the computer. Computer is an electronic equipment, right? So to interact with the computer hardware, I cannot directly interact with the computer hardware. Why? Because it is an electronic device. Whatever the language I am using is not understandable by the computer hardware. It don't know. Only electronic equipment knows only two. One is either voltage is present or not. If voltage is presented, then we'll call it as on state. The voltage is not presented, that is off state. So computer knows only one language, that we call it as machine language. In machine language, we have two symbols. One is 0 and 1. These two are called binary numbers, and the system is called binary number system. So machine language uses binary language system. So why only two states? As I say, computer understands only two, either voltage is presented or not. If the voltage is presented, then it is called as on state. That we will represent as with 1, binary bit 1. And if the voltage is not presented, then it is a 0. That's what you know, nothing more than that. So how it so interact with the, so if I want to interact with the computer, definitely I have to interact with that language only. If I interact like however I speaking right now, no, so computer can't understand that. So definitely we need one interface which converts our whatever the English language I'm speaking it, right, or whatever I'm coding it has to be converted into the machine language. So that interface is nothing but a software. So there comes into the picture of software. So previously how programmers or users were interacting means if they want to interact with the computer or hardware, then definitely they have to code in a machine language only. But the main problem was always coding in machine language or zeros and ones. It's very difficult for the human being, right? So that was the main drawback of whatever the previous existing ones. I was talking about the long back ago, it was the position. So we need an interface, that is a software. So what is a software? So software means that is not physically existed, that we cannot touch. There is a magical thing, like a software is a collection of programs. Bunch of programs is called a software. Then what is a program? So program is set of instructions. Then what is an instruction? All right. So instruction means whatever. If you have written any programming language or code, then one instruction we give like printf. Okay, printf is a function. So this is an instruction to the computer saying that, hey, computer, just print this, whatever the string I'm giving it to, print it. So that is an instruction. So the collection of instructions is a program. So programs combined gives software. So if you divide a software, this is the structure: hardware, input devices, output devices, CPU, right? So again, software. So in software, if you we divided the software into two types. One is the system software and another is application software. So first we'll talk about the system software. The system software, again, we have divided into operating system, language processor, and device driver. So what is an operating system? What is a language processor? What is a device driver? We'll talk about it. So operating system is an interface between an end user and hardware components. If you want to interact with the hardware components of a computer, then through operating system only we can interact with the computer hardware. This operating system acts as an interface between a user and a computer hardware. So what are the tasks this operating system manages? Means memory management, time management, process management, folder management, file system management. All these are the things which operating system performs. So I'll just give you an example. So if I'm running multiple applications simultaneously, let us take I have opened my web browser, I'm chatting, I open my Facebook account, and something from a different website I open simultaneously. So I'm working on that one. Then definitely that time the processor has to be executed concurrently, right? So this operating system takes care of all those actions. So it will provide the memory for each and every process separately. For whatever the Facebook application I opened it, right? So for that one, it will allocate some memory. For the web browser, it will allocate some memory, some time management, process management, which has to execute. So all these tasks are performed by operating system. So operating system, without operating system, we cannot run any application. It's very difficult for us. I would say it's impossible also without operating system. So that is operating system. Then we have a language processor. So what language processor does means, language processor converts our instructions, whatever high-level language or whatever the language we are giving, right, instructions to the computer. So this language processor converts all these instructions into the machine code. And device drivers. So device drivers are peripheral devices. Let example, I have interfaced my printer to the computer. So printer is another device. So whatever the task printer has to be done should know about operating system. Operating system should know about the printer configurations, all those things. So this device driver is a software again. So this device driver tells the operating system how to interact with that printer machine. Okay, these are the basic terms in software, system software. Next, application software. So application software runs upon operating system. Okay, so to run an application software, definitely we need a system software. Upon the system software only application software runs. Whatever the applications we are using, right, a browser is our application software, and your processor. These are the application software. Whatever the different softwares we are installing it now, right, all these are the application softwares. So this is a brief introduction about the hardware components and software components. So coming to the programming languages, so we can divide the programming language. See, programming language is nothing but the way how we are interacting with the operating system. So internally, if we interact with the operating system indirectly interact with the computer hardware. So languages, these programming languages, mainly we can divide into two parts. One is the low-level languages and another is high-level languages. So low-level languages means, what are low-level language? Low-level language is nothing but the language in low-level languages, whatever the code we are writing to the computer, it is something really closely to the machine language. So example, in the previous, the past, how programmers used to code the computer is they will write the code in machine instructions. So directly, whatever the instructions they were writing are directly executed by the machine. Why? Because these whatever the instructions they are writing is similar to the machine language. So it was very difficult. So low-level languages code is similar to the computer language. In low-level language, again, we can divide low-level language into two parts. One is the assembly language, one is machine language. So, you know about machine language right now. So, in low-level language, assembly language, machine language. So, machine language is directly to the computer language. So, what is assembly language? So, in assembly language, we use some mnemonics or symbols. Example, if you see microprocessor or microcontroller programming, so we used to write instructions like add x comma bx, sub x comma bx. So add, sub, these are all the keywords, right? Mnemonics. So already computer knows about all these instructions, these mnemonic codes. So if I write a add directly, it will add. So this, even though it is somewhat interactive with the computer user, but not fully, right? So these are the assembly language code. Even though it was very difficult for a user, right? So that programming add AX, BX, register, something, right? So it was very difficult. Then they came up with high level language. So what is high level language? So high level language code means whatever the code we are writing in high level language is something like English and some mathematical operators, the plus, minus, all these things. Whatever the programming languages we are writing, all those are the examples for high level programming language. Example, COBOL, Fortran, Pascal, C, C++, Java, Ruby, Scala, Python, all these are the examples for high level programming language. So you understand. And one more thing is low level programming languages are platform independent. That is the big concern actually. What is a platform independent mean, right? So platform independence means whatever the code we are writing into for one computer may not execute on the other computer. Platform means whatever first. If I write one program in my computer system, which has a Windows operating system, so if I take the same code and if I try to run it on a Unix operating system, it may not work. If the language is platform dependent, whatever the local platform I am using. Okay, examples for operating system. The most I forgot to say about operating systems, right? So most popular operating systems are Windows operating system and Unix operating system and Mac OS, Apple operating system. So these are the powerful operating systems nowadays we are using it. Mostly in our personal computers, we are using Windows operating system. So in Windows also we have different flavors of Windows 7, XP, or Windows 8, Windows 10, all these are the different portions of operating system. So basically, that is what a brief introduction of the how programming and how basically computer converts that. So in case of system software, I told language processor converts our whatever the instructions. If I give A, so it is converting to the machine language, right? So in case of programming languages, how it happens is, let us take I have written my one code and it is in high level language, so it has to be converted into machine language. So then I need a translator, right? So these translators converts high level language code or whatever the code I am writing into the machine language. So we have three types of translators in programming. One is a compiler, interpreter, and assembler. First, assembler will take. So assembler means it converts assembly language code into machine code. That is the task of the assembler. Then compiler. Compiler converts your high level code or whatever the source code, whatever the code you are writing, right, that is called source code. So your source code converts into machine language compiler, right? Now interpreter. Interpreters also perform the same action. It converts your high level language code or source code into machine language code. Then what is the difference between compiler and interpreter? So compiler actually what it performs is it takes whole your source code, the total source code, and at a time it converts into the executable code. In case of interpreter, it takes line by line. It takes the first line and it converts into machine language and it gives output back to the user. So in case of compiler, the delay is less. Why? Because at a time we are converting whole program into the executable file. But in case of interpreter, the delay is more. It takes line by line, right? So delay is more. But where we'll use interpreter means, so if you want to debug where the exact error happened, then it is interpretation is the best choice for debugging. Compiler means all the software is all of the operating system, all is in a compiled programming language. Nowadays, we have both compiler-based programming languages and interpreted code. Scripting languages are the right. All those are the interpreted programming, interpreted structure depends. So these are translators. So these plays very key role. Compiler. So you see when any language developed means they will tell like this is open source, so anybody can use it. Like this, they will tell like basically how it means. Open source means that whatever how they have implemented that language, we can see the source code, but they will not give you authorities to see the compiler. So compiler is a costly thing. So let us take Java only. So Java is an open source. Anybody can see how they have developed Java. They will tell open source, so anybody can see the source code. Open source means how they have developed that language. We can see the source code of that language, how they have developed the code. We can see that is means open source. Open source is not free. Most of the open source are free, but it doesn't mean that all open source are free. Open source means we can see the source code of the language. So the Java is open source, but the compilers key role, right? So however I write a program, it has to be converted into machine code. Who will do all these actions? Compiler only. So compiler should be designed in such a way that it has to understand what are the instructions we are giving to the computer. So compiler is a key part. Then we'll see about how basically the computer translates this into the machine code. We are writing an English language, but how internally it is happening. I'll just give an example of how basically these actions are performed. Okay, now let us take, I'm giving input to the computer as 2 plus 3. So I want to perform addition operation. So in computer keyboard, I press 2 plus 3. Okay, then how internally it converts to the machine language means. So when the standards were implemented, then we have one ASCII standard, right? American Standard Code for Information Interchange. So ASCII defined one standard saying that, hey, whenever you are using a computer, whenever you're developing a computer or manufacturing a computer, you have to design this all these compilers or translate it in such a way that it has to follow the standards. That so for each and every character or symbol in keyboard we have, right? So for those, ASCII defines some equivalent decimal numbers for all the characters that we are using keyboard. If I say A, capital A, 97, small a, 65. So like that, ASCII defined that standard. So everybody has to follow the standard. So whenever I press one key in keyboard, let us take A. So it is going and printing it as a console, right? A. So how it internally happens is, if I press A, then internally it converts into decimal number. So for A, the decimal equivalent decimal is 65 as per ASCII standard. So this 65, right? Again, it is converting into binary number. Why? Because it has to convert, right? So compiler converts this 65 into binary number and it gives to the processor. And processor will get to know like, yes, he pressed here, then I have to print it in console. So how basically it happens is, in this example, 2 plus 3, right? First 2, I am converting it to the binary number, 2, 3, 0, 0, 1, 1. So how to convert a decimal number in binary number, right? So let us take 10. You divide any number. If you want to convert into binary number, you divide with the 2. 2 5s are 10. Then remainder is 0. 2 2 4. Remainder is 1. 2 1s are 2. Remainder is 0. Then go from bottom to top. 1 0 1 0. 1 0 1 0. So we got the binary equivalent number, right? So this is starting index is 0th index, 2 power 0, 2 power 1, 2 square, 2 cube, 2 4, and so on like that. We have to consider. So 2 power 0 means, so whenever you want to convert again the binary number into decimal number, what we have to do is you take the instance. Okay, it is 0, so you need not to consider. You take this position 1. So 1 into 2 power 1 is 2. Here is 0, need not to consider. Here 1 into 2 cube, 8. 8 plus 2, you just add. 8 plus 2 means 10. So for 10, this is the equivalent binary number. Similarly, in this way we can transform from binary to decimal and decimal to binary. So this is how internally this transformation happens. So we have 8 bits, 16 bits, 32 bits, 64 bits, What are these? Why we are representing in 8 bit, 16 bits, 32 bits means? See, initially we were using 8-bit configuration, right? Why? Because whatever the standard ASCII defined, right? For all the keys we are using in a keyboard. So all those keys, how many keys are there in your computer keyboard, right? All those keys we can represent with 8 bit. So with 8 bit, the maximum number we can represent 256 numbers, right? So whatever the keys in keyboard we have, right? All this we can represent with 8 bits. The maximum number with 8 bits means all ones, right? 8 bits, all ones. 3, 6, 8. So 2 power 7, so on 2 power 0. The 2 power 6 configurations we get it. So all those we can. So that's why in the initial days we can work with the 8-bit operating system. So 8 bits. Then we know why we are moving means 8-bit, 16-bit means. So nowadays we can interact with the computer in different languages also. So to support different language or symbols, we have come up with 16 bits, 32 bits, and 64 bits. And one more is 32-bit operating system supports almost 4 GB of RAM. Capacity is 4 GB of RAM it supports. So whenever the system bits increases, then it supports more number of memory size also, RAM also. That's the advantage with the bits. So like this it performs actually. So who is doing all these actions means processor. So just to talk something about processor, what is there inside the processor? So processor is the brain of the computer, right? So what are the inside this processor is? It's just electronic chip. It is a chip. Inside that processor, what we have is billions of transistors. Nowadays, what are the cell phones and computers we are using, right? In the computer, almost 2 billion transistors we are using. Then what is this transistor? I would say just a switch acting as a switch. Only switch, however, is our electronic bulbs or the switches acts like. So the transistor is also a switch. The size is nanometer size. It's some 16 or 60 nanometer one transistor size is. So it's very small. So whenever I pass one to processor, so switch is just a switch, right? One means it assumes like yes, voltage is present. In electronics, 0 volts represents 0 state, 5 volts represents 1 state. So in processor, we'll have different circuits. If you are from electronic background, might heard about half adder, full adder circuits, flip flops, all these are circuits. Nothing is there. Only transistors they configured in circuits in such a way that let us take adder circuit only. So they configured this transistor in such a way that if the user wants to perform addition operation, so whatever the inputs he are giving, right? So if it is an addition operation, then this circuit performs the action of addition operation, performs it addition. Like the same way we have different circuits, addition, multiplication, division. For all those we have different circuits. So whatever things, depending upon the instructions, it goes to the particular phase and it performs the action, gives output back to the user. That is how a processor works. But the concern with now is year by year the number of transistors that we are putting in processor is increasing, so that in that way we can increase the speed and efficiency of a computer. But the problem is if you put more number of transistors, then the size has to be reduced. So if you decrease the size of the transistor to small piece, small I would say, then what happens is the barrier, if from electronics you might be knowing about this. So in transistors we'll have a barrier, right? This barrier length is decreasing, so that the depletion region, now we got the point, right? The depletion region width is decreasing. So if the depletion region is decreasing, the p-type and n-type semiconductors are combining. So that was the problem we are facing it from last 1 year. That is what the concern for all the processor designing. But for every year, the number of transistors should increase in a processor. But if they decrease the size of the transistor, that is what the problem they are facing it. That is Moore's law. As per the Moore's law, the number of transistors should increase for portion and version. For different portions, if you are going to higher version, definitely you should have more number of transistors. That is what the problem with this integration. This is a brief introduction about how computer works and the introduction to the programming languages. Just to all over the program, I have not gone through the deep into the programming languages. So in in next session we'll talk about separately about programming languages only. What is a programming language? Different types of programming languages, like from Fortran, see how C came into picture, and how Java. Now, what are the programming languages we are using it, right? How they came into the picture. We'll talk about that in next session. Hope you guys enjoyed this lesson. Thank you for watching this. Have a great day. We'll see you. Bye bye.